Hi there, it's Natalie Topa, and I'm here in my apartment in Nairobi and realized I haven't really made a full video tour of the types of ways I'm trying to integrate permaculture practices into my life in my urban apartment. So I'm going to give a tour of all the different types of things that I'm trying to experiment with here and test, some which maybe aren't very conventional. But the reason I'm doing this video now is because I'm actually moving out of this apartment into a new apartment, and tonight we're sealing the door of the beehive because tomorrow we're going to be transporting the bees to the new apartment. So I'm here on a fourth floor farm. So this is a type of farm. It's my balcony garden here in Nairobi, and the bees that we're relocating are here. These are stingless bees from Kenya, from Kakamega region, and they're tiny little micro bees. And I just thought I should have them here so that I can try to create an opportunity for pollination. We have different plants. While we still have them here in Nairobi, the skyline is changing very quickly. So we have bees here, and we did have another bee shelf here, but that beehive was attacked by mites. Actually it already had mites in it and died. So this is the garden that we have, and really quickly we've got yams here. There's a passion vine. Most of these are chayote squash, which is this fruit or vegetable here that I use to make kimchi or Indian sambar. This is a chaya spinach tree, miracle tree. This is an edible leafy green vegetable, and it's like in a juicy stemmed plant. So we have those in the various pots. We've got a lot of amaranth here and molokhia, which is jute. We've got nasturtiums and mint and coriander and kales and catnip and lots of things here. And really trying to use vertical spaces as well as just, the ground and the pots. So I made these climbing trellises on both sides, just using recycled materials, and this is something very easy to do in small spaces in the displacement context, refugee camps and shelters. And this side here, because I wanted a bit of privacy and shielding this building and kind of keeping this side open, I created this what I call leave me alone. So we planted more heavily on this side, and we have these binding wires which are very inexpensive. You can also use shoestrings, old cables, old wires, even clothes that are, tied into long strings, all kinds of recycled materials. So here, even on the small space, which is my balcony, I'm able to have some food production and have a home for the compost. So I make compost here at home, and I'll show you how we do that. There are a number of different things that we do in the apartment to try to cycle waste. So here in the kitchen, there's this clay pot, and I kind of like to use a beautiful thing for compost. It doesn't have to be ugly, stinky, or smelly. Every single day this is emptied into the compost, and I'll come back and show some of those fertilizers. In the meantime, let me take you to where we do our compost. So why I think this is so key is because we're demonstrating here what can happen in an urban environment. And in this apartment building, we have a waste disposal function where people come and remove all the garbage and take it to the dump yard. But what we do, all of our organic waste, carton boxes, food waste, all of that comes into this room. And these 4 bins, 1, 2, 3, 4, are full of earthworms and compost. So every day, all of the food waste gets dumped into here. And if you keep digging, you'll see earthworms, but it's kind of hard because I've got one hand. So each of these has earthworms, and from that we get very, very rich compost. Here we also have mealworms. So these are darking beetles that create these larvae, which are great chicken feed. And in my previous apartment, we had a chicken compost system on the balcony. So here, this is where we put the spent chicken mash, and you've got the eggs that hatch here. And so mealworms are, they also consume stems and potato peels and things like that, and they provide a great food source for poultry, for fish, for piglets. So all of the compost, food waste, carton waste, paper waste, that's also the room where we make the mushrooms. There are oftentimes mushrooms that I make, oyster mushrooms. So I did also want to show, I've taken a number of composting courses, including a master composting course with Peter Ash. And composting toilets are something that can be integrated safely into biological processing of human nutrient in various contexts. The Philip Merrill building, the Philip Merrill Environmental Center, is the headquarters building of the Chesapeake Bay Foundation in Maryland, and they actually have a Class A office building that does compost. So here in this spare shower, I have the safari toilet, so people in Kenya will be very familiar with these. But basically I've got sawdust here, and I've got charcoal dust, which is a waste product. Both of these are waste streams or resource streams. And I've got this bottle of lactobacillus serum. So basically, last March, I filled this up with my own nutrient, and there's virtually zero smell at all. So every time I made a deposit, I added sawdust as well as charcoal dust, and then sprinkled lactobacillus serum. Why I sprinkled the lactobacillus serum is because that hastens the decomposition, but it also is a odor-eating bacteria, so that helps to reduce the smell. And so I'm experimenting with that. The plan is to let that just stay put for about 6 months, and then I'll add like a kilo of worms, red earthworms, and let them work through that for a number of months as well. And then I'll have that tested. So the other things that I've done here in this apartment is to grow spirulina. Spirulina can be grown with human urine as a nitrogen source, and then baking soda to manage the pH, and we have a microscope and make sure that that's all safe and everything. But what I also wanted to show is that these are liquid biofertilizers that I make at home. My family is from Poland and Ukraine on my father's side, so fermentation is something that I grew up doing as a child, and it's something that I've carried on doing because it's very easy to make liquid biofertilizers from household resource streams. I think we can sometimes use the word resource instead of waste. So, for example, eggshells. Eggshells can be fermented and have a lot of great properties. Here we have offcuts of calamari. I like to cook a lot at home, and so when I have these little odds and ends, they can be fermented safely to create a very rich biofertilizer. So I mentioned before that I had a beehive that didn't make it, so I decided I'm sure that's got plenty of nutrients in it, so I fermented that one, beehive ferment. Here we have Maasai honeycomb that I fermented. This is lactobacillus serum, which is easy to make. I make it with rice wash, raw milk, and that's it. You just curdle that, and that becomes lactobacillus serum. This is wood vinegar that I made during a training that I did for the team in Dadaab refugee camp when I was working with the Danish Refugee Council. There we also were processing goats because we had a big team, and every week there were about 2 goats that were slaughtered for food, and so I took the raw skin and fermented that. Sorry, vegetarians. Eggshell ferment. So once again, this is packed full of calcium and all kinds of things. So we fermented that. So what I mean by ferment, I add this to my Polish fermentation crock, with a splash of labs and a sugar source, like molasses or sugar, or you can use other things, jaggeries. And then let that sit and ferment. And as I always say, the nose knows, okay? When it stops smelling like Satan's outhouse, it's ready. So we've got goat skin, eggshell, crab shell, beehive, prawn shell, Maasai honey wax ferment, and then mixed crab, oyster, and clam ferment. So all of these are things that end up in dumps that, you know, end up contributing to a public health hazard and disease because they're not able to be processed biologically and as they would in nature. So we're creating that natural system of biological processing in the bottles here. So what I also wanted to show, which is interesting, is that I actually have had these tested in the lab. So I sent samples of some of the ferments to crop nuts here in Nairobi, and I'll just show you some of the results, which are quite amazing. So for example, here, I also, in my previous apartment, had a farm for black soldier fly larvae, and when they pupate, they leave behind a shell, which is actually contains a lot of chitin, and chitin is currently being studied and researched, R&D'd, as a plastic alternative. So there's a lot of value in the shell itself, but I fermented the shell, and if you can see this, let me just expand this a bit. So I took the shells, fermented them, and if you look at the levels, look at here, we have the parameters, all of the different properties, nutrients, minerals, and this is low, optimum, and high. So just take a look at some of these levels from the pupa shell of the black soldier fly larva, okay? All of these, the only thing that was low was pH, and otherwise, in every other instance, they had either optimum or high levels of all of these plant required nutrients. So let me just take a look here, the beehive ferment, right? The beehive ferment, again, low in pH, but everything else super, super high of all of these levels. I hope everyone can see. Same thing over here. So if you just take a look here, oops. So this here is the eggshell ferment. Look at high levels of everything, optimal to high, okay? Let me just see if we can go to the next one. We fermented goat manure, also with lactobacillus serum. So lower on the pH, but all of these other levels that are optimal or high. Goat juice ferment. So this was that skin of the goat that I cut into little 1 square inches and then fermented it raw. High or optimal on everything, on every marker here. I think that might be it. So yeah, the reason I wanted to show this is because, you know, there's increasing push for fertilizers coming from imported supply chains, and it's just not necessary. It's not necessary that we use the fossil fuels to deliver petrochemicals to farmers and soils that actually are harmful, right? Even fertilizers, not only pesticides, are problematic for soil life, and they're just not necessary, right? They're not necessary because we can convert resource streams into value streams in a circular manner to create the fertility and fertility management products and regenerative microenterprise for communities using all of the rich resources that we have all around us. So that's just a brief tour of the things that I'm trying to test out in my home, and also just to really show the kinds of potential, even for very, very small spaces, micro spaces around shelters, in camps, settlements, urban spaces, rooftops. There's just really so much potential. So I hope that was interesting and inspirational, and thanks for watching. Thanks, bye.